Hello guys, welcome to XY 101. In this video, I will be teaching you about valence electron or how to determine the valence electron of an element. So before anything else, let's start with trivia. So our trivia for today is all about, did you know that the longest word in the Merriam-Webster dictionary is pneumonia ultra microscopic silico-volcanosis. Again, the longest word in the Merriam-Webster dictionary is pneumonia ultra microscopic silico-volcanosis. So it refers to a lung disease caused by inhalation of very fine silica usually found in volcanoes. That is our trivia for today. So let's start with our discussion. So our discussion is all about valence electron. So before you able to understand what is valence electron, I will recall some informations that can relate to valence electron. So are you familiar with this picture? Okay, this is the structure of an atom. Structure of an atom. So what is an atom? So atom is the tiny particles, or it is the basic unit of an element. And according to John Dalton, atom is building blocks of element, and then it is very tiny, invisible, destructible particles. So what an atom composed of? So atom composed of subparticles. So what are the subparticles of an atom? So the subparticles of an atom are the following. We have proton and neutron and electron. Again, what are the particles or subparticles of an atom? Neutron, proton, and electron. So where do you find electron? Okay, very good. You will find electron outside the nucleus. What about neutron and proton? So you will find them inside the nucleus. So we have another picture here. We have the structure of aluminum. So, do you know the atomic number of aluminum? Okay, the atomic number of aluminum is 13. So, 13. So, in this picture, you will notice we have 13 dots. So, those dots represent to the atomic number of aluminum. So we have 13 dots. And then at the first orbit we have how many electron? Okay, we have 2 electrons in the first orbit. And then the second orbit we have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And the last orbit we have how many electrons? 3. We have 3 electrons. 1, 2, 3. So, in our topic is all about valence electron. So anyone here can guess the valence electron of aluminum. Okay, later we will find out what is the valence electron of aluminum after we discuss about valence electron. Okay, so when we say valence electron, from the Greek word valentia, it means that it is the capacity to form bond. So do you still remember the different chemical bonding? So we have ionic bond, covalent bond, and metallic bond. So in our definition, another definition for valence electron, so when you say valence electrons, are the electrons in the outermost in the outermost level of an atom. So in this visual aid, you will see the definitions of valence electron. So are the electrons in the outer energy level of an atom, and it determines the group of an element. Again, it determines the group and element. So always remember that for you to able to determine the valence electron of an element, you have to draw the electron configuration. So the question is, how are the valence electron and the group number of an element reflected in electron configuration? We will find out. So before anything else, I will discuss about this one. So 1s1. So do you still remember the 4 subshells? So we have 4 subshells. First one, we have S subshell, P, D, and F. And every subshells, there is standard value. So what is the standard value for S subshell? Okay, very good. That is 2 for S, and then P is 6, and then D is 10, and then F is 14. Always remember that. And then you will find those subshells in a periodic table. Okay, so this is the number is what we call principal quantum, or the number of subshell. And then the S is what we call subshell. Again, S is subshell. And then the 1, or the exponent of S, that is what we call the number of electrons in a subshell. Are you getting me? Are you following me? Okay, so after that, I will be giving you an example so that you can follow what I'm talking about. Again, so when we say valence electron is equal to the total electron population at the highest principal level, or quantum number as indicated in a electron configuration. Okay, now I will be giving you an examples how to determine the valence electron of an element. Okay, first example, we have Be. So what is Be? Okay, that is beryllium. So what is the atomic number of Be, or beryllium? Okay, very good. That is 4. So the atomic number of beryllium is 4. So let's draw the electron configuration, because always remember that electron configuration can help to determine the valence electron of an element. So 1s2, 2s2. Again, 1s2, 2s2. This is the electron configuration of beryllium. So therefore, what is the valence electron of beryllium? Anyone? Okay, very good. The valence electron of beryllium is 2. So how can you get the 2? Or how did you get the 2 valence electron of beryllium? Because the highest principal energy level of beryllium is 2. And then the number of electron of 2 of S subshell is 2. So therefore, the electron configuration of beryllium is 4. Again, I will explain our first example. Okay, again, we have beryllium. So what is the atomic number of beryllium? Again, I will explain our examples so that you can really understand the valence electron, or how to get the valence electron of an element. So we have 2 examples here. Okay, another example, we have beryllium. The atomic number of beryllium is 4. So always remember that the atomic number is equal to number of an electron. Atomic number is equal to the number of electron of an element. So if you are going to write the electron configuration of radium, we have 1s2, 2s2. So therefore, our valence electron is 2 because the electron of the highest principal energy level is 2. Always remember that. And then, if you are going to write the atomic model of beryllium, we have this one, beryllium, this is the nucleus, and in the first energy level, we have 2 electrons, 1, 2. And then the second energy level, we have 2 electrons also. So that is what we call valence electron. We have types of electron, valence electron and core electron. The core electron are the electrons, again, the core electrons are the electrons in the innermost energy level of an atom or element. While valence electrons, those are the electrons in outermost energy level of an element or an atom. Don't be confused with that two types of electrons. Okay, another example, we have calcium. So what's the atomic number of calcium? Okay, 20. Okay, 20. So if we are going to write the electron configuration, 1s2, 2s2, 2p6, 3s2, and 3p6, and 4s2. So what is the valence electron of calcium? Okay, the valence electron of calcium is 2. So how did we get 2? So the highest principal quantum or the principal energy level of calcium is 4. 4, and then the electron at the highest principal quantum of calcium is 2. So that's why our valence electron is 2. And then if you are going to locate beryllium and calcium in the periodic table, you will notice that you will find out that beryllium and calcium are located or belong to group 2. Just like what I mentioned earlier, the valence electron can determine the group number of an element or an atom. Okay, in this part, I will answer the activity, or we are going to answer the activity so that we can apply what you have learned in this discussion. So the first one, we have helium. So what is the atomic number of helium? So 2. So if we are going to write the electron configuration, 1s2. So therefore the valence electron is 2. Okay, another one, we have lithium. So what is the atomic number of lithium? Okay, 3. Tama? It's correct, 3. Okay, 1s2, 2p, 2s1. 2s1. So therefore the valence electron of lithium is 1. Can you follow? And then another one, boron. What is that? Atomic number of boron. Okay, very good. 5. So 5, 1s2, 2s2, 2p, 1, 2p1. So therefore, the highest principal quantum is 2. So we have to add 2 plus 1 is equal to 3. Then this one, we have to plus this electrons. And then another one, carbon. What is the atomic number of carbon? Is 6. So 1 is 2, 2 is 2, 2p, 2. So therefore, 2 plus 2 is equal 4. And then another one, we have nitrogen. So what is the atomic number of nitrogen? Okay, 7. So 1s2, 2s2, and then 2p5. So if we're going to add the electron of highest principal quantum, we have 2 plus 5 is equal to 7. So you will notice that the group number of the given elements are equal to the number of valence electrons. Okay, that's for all for today. If you have any comments or suggestions, just comment below, and then don't forget to subscribe to my YouTube channel. Thank you so much.